Welcome to David Alexander Maths Tuition. This is chapter 6e on tangent and chord properties. Okay, so here's the first example. We want to verify that the point P lies on C. Well, point P has x equals 5 and y equals 1. So if I substitute them in, if I get 49, it lies on C. If I don't get 49, it does not lie on C. So 5 plus 2 is 7. 7 squared is 49 plus 1 take away 1 is 0. 0 squared is obviously 0. And 49 plus 0 is of course 49. So it definitely lies on C. Okay, now we need to find an equation of the tangent. So first of all, we need to remember a couple of things. We need to remember that we can work out the centre of the circle from the equation. Well, that's nice and easy. The coordinates of the centre are -2, +1. And we need to remember that if I can work out the gradient of the radius, then the gradient of the tangent is the negative reciprocal, since they are perpendicular to each other. Okay, so usually what I would do here is work out the gradient using changing y over changing x, and then work out the negative reciprocal, and then work out the corresponding c value. However, here we don't need to do that, and the reason why is because the y values are the same. Think of it like this. So here is, okay, not drawn a great set of axes there. So -2, 1 is here, -2, +1. So this is the centre, and here is 5, 1. Okay, so this is my radius. So therefore the tangent will be perpendicular to the radius. Since the radius is perfectly horizontal, the tangent will be perfectly vertical. Now the radius has got an equation of y equals 1, so therefore the tangent will have an equation of x equals 5. So that is quite simply the equation of the tangent. It is x equals 5. So a bit of an unusual example, this one. Like I said before, usually it's a question of working out the radius in terms of y equals mx plus c. Well, actually, you don't need to work out the c, you just need the gradient. And therefore, for the what's it called again, the tangent, we're using the negative reciprocal, and we're substituting in. So once we've done the negative reciprocal, we know it's y equals whatever m is, and then the c value we can work out by just substituting in the points, well, the coordinates where the radius, well, the known point that the tangent goes through. Okay, so here's a slightly more challenging example. Now the question talks about the midpoint of the line segment PQ, so probably a good idea to work out what m is. So -7 + 3 halved is -2, and the midpoint of -1 and -5 is of course -3. Now we've been told that the line passes through the points M and C. Now we don't know what C is, so it almost looks like there's not enough information to go on. However, we need to draw on a little bit of new knowledge, which is that the perpendicular bisector of a chord goes through the centre of the circle. So if this is point P and this is point Q, we've worked out the midpoint, which is M. So the perpendicular bisector of this line goes through the centre. So what I'm going to do is I'm going to work out the gradient of the line PQ. So if I can work out the gradient of this line, obviously this sketch might be completely inaccurate. Well, I strongly suspect it is. If I can work out the gradient of the chord, then the negative reciprocal will be the gradient of this perpendicular bisector. So changing y over changing x, that's -5 take away -1 over 3 take away -7, and subtracting a negative is the same as adding, of course, so that's going to be -4 over 10, so -2/5. So this chord, that is y equals -2 over 5x plus c, so therefore the perpendicular bisector will be y equals +5 over 2x plus c. Now we do know that it goes through M, so therefore I can work out what this c is. So y take away the y value, so y take away -3, y plus 3 equals 5 over 2, lots of x, take away the x value, take away -2, and subtracting -2 is the same as adding 2. So y plus 3 is 5 over 2x plus 5 over 2 times 2, which is 5. Take away 3 from both sides. So y is 5 over 2x plus 2. So that is the equation for L. Y equals 2.5x, or 5 over 2x plus 2. Now we know that the y coordinate is -8. So what is the x coordinate? So just substituting -8. So -8 is 5 over 2x plus 2. Take away 2 from both sides, so -10 is 5 over 2x multiplied by 2 minus 20 equals 5x. Divide through by 5 minus 4 equals x. Perfect. Okay, so nice and easy. We know that the coordinates of C, if I just write them here nice and clearly, is okay, -8, -4. Okay, sorry, we were just proving it was -4. So if this is the center of the circle, then the equation of the circle is going to be x plus 8 all squared plus y plus 4 all squared equals something. Okay, now we know that we've got 2 points that lie on the circle, so we can substitute them in to work out my r squared. So let's substitute it. It doesn't matter which one we use. Let's go with 3 and -5. The reason we're using these is because these are points that lie on the circle. We can't use the midpoint of the chord. We can't use the center of the circle. They don't lie on the circle. So the only reason I'm using 3 and -5 is because 3's positive, and here I've got 2 negative numbers and I don't like negatives. So 3 plus 8, so that is 11 squared, so 121, plus -5 plus 4 is -1. -1 squared is 1, so that is 122. So the equation of the circle is x plus 8 squared plus y plus 4 squared equals 122, and we are done there.